Okay, so this next video we're going to do is going to be a little break from algebraic fractions. We're going to do factorization, but then we are going to go back to algebraic fractions to finish them off. So that's if you're watching them in order. Again, you can watch them in any order you want, but we'd recommend watching them the whole way through. So we'll start off. What is factorization? So first we'll start off with what a factor is. So a factor is any two numbers, so that you multiply by each other to get whatever number you want. So it's difficult to explain it in words. The best way to do it is with an example. So the factors of 8 are the two numbers that you multiply by each other to get 8. So they would be 1 times 8 and 2 times 4. Okay, so that means the factors of 8 are 1, 2, 4 and 8. Yeah, does that make sense? So the factors of 8 because the numbers you multiply them by each other to get 8. Okay, so we need to go through what a factor is first. Then we're going to go into prime numbers. Okay, so prime numbers. Hopefully my handwriting is okay. Prime numbers are numbers that have no factors except themselves and 1. Okay, so examples are 7. There are no two numbers that you can multiply by each other to get 7 except for 1 by 7, okay? I'll give just a quick list of the prime numbers. I'll do in a different colour. From, I don't know, so there's 2, 3, 5, 7, 11, 13, and so on. 1 isn't a prime number. Yeah, that's all you need to know really about prime numbers, okay? Next. Okay, so now we're going to go on to how to factorize something, okay? So there's factorization. Go to green for this. So there are 3 main methods, okay? 3 methods. 1 is going to be inspection. And through inspection, looking for the HCF or GCF, which stands for highest / greatest common factor. So that's just a fancy way of saying you're looking for the highest number that's a factor of both of them. So again, this is best explained as an example, so we'll go straight to an example. 3x squared minus 9xy. Okay, so if we want to factorize this, basically like factorizing generally, you're going to be putting the numbers in brackets. Okay, so two things multiplied by each other, so two separate brackets. So the highest number, or the greatest common factor, so the highest thing that goes into both 3x squared and minus 9x, in this case it's going to be 3x. So we're going to take 3x out, okay, of the brackets, and we're going to put the rest of the things into the brackets. So if you divide 3x squared by 3x, you're going to be left with x, and 3x into minus 9xy, you're going to be left with minus 3y. So this is it factorized. If you multiply that out again, you're going to get 3x by x is going to be 3x squared, and 3x by minus 3y is going to be minus 9xy. So this is factorized now. So this isn't exactly very useful right now, but when we're dealing with really complex equations and stuff, and you can factorize things and simplify them, it's really helpful, okay? I'll just do one more quick example of this. So if we have 2a squared b, okay, and careful, that means the a is squared, but the b isn't squared, okay? Minus 4ab squared, and again, be careful, the a isn't squared in this, it's just the b that's squared, okay? Plus 12abc, okay? Equals, so we're looking for the highest common factor. So again, the number that goes into all of it has to go into every one of these terms, and we're going to take it out of the brackets. So in this case, it's going to be 2a. Okay, hopefully I can squeeze these all in. So if you divide 2a into this, you're going to be left with ab. This one, you're going to be left with minus 2b squared, or minus 2b squared. Yeah, sorry. Minus 2b squared, so again, because 2a by 2b squared is going to be minus 4ab squared. And then this last one then is going to be plus 6bc. Okay, so again, this is as factorized. You take one thing out of the brackets, the highest common factor, and the rest of them will remain in the brackets. So the idea generally is that you'll hopefully cancel this 2a with another 2a somewhere else in the equation. We'll go into those ones later, okay? So this is the first method we're going to look at. The second one then, I'll change colour for it again, I'll go to blue, why not? Is going to be difference between two squares. So I'm just going to go diff to squares, the difference between two squares. So this is always going to be in the form of x squared minus y squared. And this is just an example you just have to learn. You have to learn to be able to spot this. If you factorize this, it's going to be x minus y and x plus y. Okay, so it doesn't matter which order you put them in, but you have to learn it off. It's x minus y and x plus y. So it doesn't always just have to be x and y, it can be anything. So another few examples we'll look at that get a little bit harder. If you have 4x squared minus 9y squared, okay, you're going to break this up into 2x all squared. So if you square all of this, you're going to get 4x squared minus 3y all squared. So if you square 3y, you'll get 9y squared. And careful, it's always a minus in the middle. If it's plus, you can't use difference of two squares. It has to be a minus in between the two terms, okay? That's going to then be equal to, exactly like we have above, it's going to be 2x minus 3y, and it's going to be 2x plus 3y. Okay, so the same thing as we have here, whatever, it's something squared minus something squared. So if you have in this form here, you're going to have to simplify it into kind of this form here. So in the form of something squared minus something else squared. So once you have it into this, so see, hopefully I'm not saying something too much and it still makes sense. So 4x squared minus 9y squared, you can say that 2x all squared minus 3y all squared, and you can factorize that into 2x minus 3y, 2x plus 3y. Okay, move on one more. Sorry. And now there's one more hard example of difference of two squares. Is going to be if we have something like this. Okay, I'll just redo that x there. Give me a second. Oh, okay, this never works. Never mind. X minus 9. Okay, so that's an x. It's not too messy. Yeah, x minus 9 here. So this doesn't look like anything like x squared minus y squared. It's a little bit of a trick. So they generally won't ask this. Hopefully this never comes up, and it probably won't. But just in case, we're just going to have you covered. So you can actually write that as the square root of x squared minus 3 squared. Okay, because if you square the square root of x, you're going to get x, and if you square 3, you're going to get 9. So you can simplify this difference of two squares to get the square root of x minus 3 and the square root of x plus 3. So you generally will never have to do that, but just if you do have something you need to simplify, say if you see the square root of x minus 3 in a fraction somewhere, and you have maybe an x minus 9 above, you might have to do this. Generally won't come up, but just to cover you, okay? I don't think we're going to have much space for the last one, so just bear with me while I get rid of this here. So hopefully you can just rewind the video and watch that again if you want. But if we're going to make space, we're going to have to squeeze the rest of this in. So the last one is factorizing quadratics. So everyone has their own way about factorizing quadratics. So what I'd recommend to you is that you stick with your own method, just to try and stay familiar with the same thing. It's kind of late to change in the day. So go this light blue here. The third method is quadratics. Okay, so try and stick with your own method. If you don't have a method you're not totally sure on, then you can use this one. But if your teacher did teach you something else, try and stick with that, because it is difficult to try and swap between methods. So we're just going to show you the method that we use in ExamLearn here. So we'll use the example here of x squared plus 3x minus 18 is equal to 0. Okay, so the first thing you're going to look at is the last number here. Okay, so quadratic first, to explain it, is something with an x squared term, so we have x squared here, an x term, so plus 3x, and then a constant, something without an x, minus 18. Okay, so x squared plus x plus constant. It can be minus, it can be minus plus, it can be whatever, but as long as it's an x squared, an x, and a constant, so just a number. Okay, first thing you're going to look for is you're going to look for the factors of the constant of the last number. So the factors of minus 18, okay, so not just 18, are going to be minus 1 times 18, not 9, minus 1 times 18, minus 2 times 9, minus 3 times 6, and so on. Okay, so you have to find the two factors of minus 18 that when you add them together, okay, so add them together, you're going to get this number here in the middle. So plus 3 is what we look for now. Forget about the x for now, but the plus 3. So we've seen it's the third one here. If you go 6 plus 6 and minus 3. So if you add these two things together, you're going to get plus 3, which is exactly what we have here. So we can use these two numbers. You might have to go through a whole massive list of them until you see it. And you might not even have to write these out. You might be able to do it in your head. But the safest way is always to write them out. So you can. It gets extra complicated when there's minuses involved. And you have to say, is it minus 3 times 6 or plus 3 times minus 6 and everything like that. So in this case, it's going to be plus 6 and minus 3 is equal to plus 3. So we know these are the two factors we're going to use. Okay? So now we're just going to write it like this. We're going to have x plus 6 in this bracket and x minus 3 in this bracket equal to 0. And you're done. Okay, so you need to find the two factors of minus 18 that are this, that when you add them, you get the number in the middle, and then you stick them into your brackets like this, and there's your quadratic factorized. Okay? And there's actually one more thing we're just going to add in at the end. What color haven't we used? I used green. No, actually, sorry, just bear with me. I'm going to have to erase this again. Okay, so again, you can rewind if you need to keep an eye on that, or you can pause or whatever. The last one here again. Now again, this is another thing that you won't see that much. Hopefully it doesn't come up, because it's just something you really have to learn off by heart, which is a bit boring. Nobody likes learning things off by heart. It's much easier if you understand them and you can recreate them yourself. What did I say? What color? We use red. And go back to a normal size pen. Okay. This is the difference between two cubes, not two squares. Okay, so again, these are things you just need to learn off by heart. They generally don't come up very often, but we'll show them to you anyway. So the two examples, that's going to be x cubed minus y cubed, and again, you just have to learn these off by heart, so it's nice and boring. X minus y, and then you're going to get x squared plus xy plus y squared. It's going to fix that. Okay, so x cubed minus y cubed is going to give you this, and then x cubed plus y cubed is going to give you this one here. So they're really similar. There's just a few minuses in the difference, which means it's quite tricky to learn, but plus y squared. So there they are there. We'll just let you learn them off. There's not much else you need to know about them. Just they need to be learned off. They're kind of annoying and boring, and they generally don't come up, so that's good. But anyway, thanks for listening. I hope the video wasn't too long. It was a bit long one, but we'll see you next time.